Question number 7. An ammeter of resistance 0.81 ohm reads up to 1 ampere. The value of the required shunt to increase the range to 10 ampere is A 0.9 ohm, B 0.09 ohm, C 0.03 ohm, D 0.3 ohm. And the correct answer is B 0.09 ohm. 7b. We can just see this is the ammeter which has a range 1 ampere and its resistance is 0.81 ohm. Now we have to convert this, or we have to increase the range, or you can say convert into ammeter of range 10 ampere. So this will become now a new ammeter with range 10 ampere. So here it will only 1 ampere. So here it will be 10 minus 1, that is 9 ampere. And according to Kirchhoff's mesh rule, we can have 1 into 0.81 should be equals to 10 minus 1 into S. So it will be 1 into 0.81 equals to 9S. So S will be equals to 0.81 divided by 9. That will be equal to 0.09 ohm. So the first option is 0.9 ohm, which is not correct. Second, B option is 0.09 ohm, which is absolutely correct. And third is 0.03, which is not correct. And D is 0.3 ohm, which is again not correct. So the correct answer is B. Seventh B is the correct, that is 0.09 ohm. Eighth question. An electron with angular momentum L moving around the nucleus has a magnetic moment given by A. EL upon 2m, B. EL upon 3m, C. EL upon 4m, and D. EL upon m. And the correct answer is A. EL upon 2m. Here we have nucleus and the electron is revolving around the nucleus with the radius r, we can say. So magnetic moment is I into A, that is I into pi r square. Here we are given angular momentum L equals to, and that must be mvr. So from here we can get r equals to L upon mv. Now the current is charge flowing per unit time. So here the charge is E and it is passing through this complete circle in one time period. So it will be E upon time. So this time period will be 2 pi r divided by the velocity. So it will be EV upon 2 pi r. So substituting the value of I and r in m, we will get m equals to EV upon 2 pi r into pi r square. So this r square will get cancelled with this 1 r. Pi cancel out. So you get simply EV r upon 2. So the value of r is EV upon 2 and L is L upon mv. So V gets cancelled. So you get EL upon 2m. That is the magnetic moment. And the correct option is A. EL upon 2m. So m equals to EL upon 2m is the correct answer. Ninth, the large scale transmission of electrical energy over long distances is done with the use of transformers. The voltage output of the generator is stepped up because of A. Reduction of the current, B. Reduction of the current and voltage both, C. Power loss is cut down, D. A and C both. So A is reduction of the current, yes. When voltage is stepped up, then current gets reduced, one correct. And C, power loss is cut down, that is also correct. So the correct option is D. As we know, the power loss for long transmission is inversely proportional to the V square, and that is why while we transmit power from the power station, we step up the voltage to minimize the loss, power loss. So according to principle of the transformer, Vs into Is equals to Vp into Ip. So Vs will be equals to Vp Ip upon Is. So when voltage is increased, to keep this factor the same, this Is has to be reduced. So current is reduced and power loss is cut to be ensured, it should be less. So here the correct option is A is also correct, reduction of the current is also correct, as well as C, power loss is cut down is also correct. So the D option is A and C both is correct. Tenth, the diagram below shows the electric field E and magnetic field B components of an electromagnetic wave in a certain time and location. The direction of the propagation of the electromagnetic wave is A, perpendicular to E and B and out of the paper of the plane of the paper. B, perpendicular to E and B and into the paper, plane of the paper. And C, parallel and the same direction of E and parallel and in same direction as B. The correct answer is A, perpendicular to E and B and out of the plane of the paper. So 10th A, here we have this is the magnetic field and this is the electric field. We know the direction of propagation is given by the pointing vector. That pointing vector is E cross B. If we neglect this constant for the direction, so we get S is E cross B. That means this direction of propagation is perpendicular to E and perpendicular to B, absolutely correct. But where the direction will be there? If you make the corkscrew rule, then E cross B means the screw is to come advance out of the board, that is out of the paper. So the correct option is perpendicular to E as well as B and out of the plane of the paper. So the correct option is A. 11th, in a coil of resistance 100 ohm, current is induced by changing the magnetic flux through it. The variation of the current with the time is as shown in the figure. The magnitude of the charge change in flux through the coil is A, 200 Weber, B, 275 Weber, C, 225 Weber, and D, 250 Weber. That correct answer is 250 Weber, that is D part. So this is the D. So here the variation is shown like this. Here it is the time. It is 0.5 seconds. Here it is current and this is 10 ampere. So we know E equals to, and R is given to you 100 ohm. We know that E equals to d phi by dt as far as the magnitude is concerned. If we neglect the direction, we are only interested in the magnitude. So E is equal to d phi by dt and current is always equals to E by R. That means this is E d phi by dt upon r. So here d phi will be equals to r I dt. If we have to find the total change in flux, the total flux, so that will be equals to integral d phi, that is r integration I dt, and from 0 to 0.5 seconds. So this integration is nothing but, if we consider a very small strip of thickness dt here, so this is the area, that is the d phi. So d phi will be equals to I into dt. So this is the area of the strip equal to d phi. If we have to integrate this whole or total flux, then we can have the area under the graph. So that means this phi will be equals to r into area under the graph. So that is nothing but resistance is 100 and area of this graph will be equal to half, base is 0.5 and height is 10. 10 into point decimal 5, there will be 5, then this will be 500. So that will be 500 divided by 2, that is 250 Weber. So the correct answer is 250 Weber, that is the D. 12th, the energy of an electron in nth orbit of hydrogen atom is En equals to minus 13.6 upon n square electron volt. The negative sign of the energy indicates that A. Electron is free to move, B. Electron is bound to the nucleus, C. Kinetic energy of electron is equal to the potential energy of the electron, and D. Atom is radiating energy. En equals to minus 13.6 upon n square EV means the negative sign indicates that the electron is bound to the nucleus, or electron is bound to the nucleus, because if we supply some energy, then it will shift to the higher level of energy, that is minus 3.4 electron volt. This is minus 13.6 electron volt. Then again it will be equal to 1 point something and so on. So if we supply energy, then it is able to move to the higher energy level. That means this negative sign is indicating that this electron is bound by the nucleus here. So correct option is B, electron is bound to the nucleus.